Hello everyone. It says we've been live for 8 seconds now. Okay, Cameron, you were saying?
Hey people, this is Cameron. We're gonna have to take this portable Tesla coil out to the forest and do a photo shoot in the river with it because it runs on 4 AA batteries, and you could just set that on a rock in the river and you could just make the most beautiful shot.
This is battery powered. 6 volts, right?
6 volts.
It's 4 AAAs, the small ones. 4 AAA batteries. Okay, so should we talk about what we're learning?
Yeah, I came over and you had these large metal plates and large thin plastic and the need for hole saws and a brain full of ideas about getting energy.
This is aluminum sheet here. Should we show the over here what we're doing? So this one's plugged in.
Sure.
And if you want to learn more about this, study Rick Friedrich YouTube channel, and he actually shows how to use copper and aluminum plates. Not like I'm doing here. I don't have the hole cut in that yet. But this is my first testing I wanted to do. I just wanted to use, this is an aluminum kind of cube, and it's not touching the plasma ball, but it might be too close to it. You can see that light turning on and off as I touch this. Isn't that interesting? So this is, the light's connected to, so this wire connects to the aluminum plate and connects to one side of the fluorescent, I think this is called a fluorescent bulb. The other side of the fluorescent bulb's connected to ground. And the ground, I'm just using the ground out of the plug there. That's the ground. And it goes to this side, so if I disconnect it, it's not as bright. Let's see if I touch it. Oh yeah, it gets brighter when I touch it. So right now it's using me as a ground, right? That would be an air ground, I think, because I'm grounded to the air. But this is going to be a ground. Oh, you see that spark there? Let's see if we see the spark. So, all right, so we want to talk about what we're thinking about?
Tell me what you to gather the energy in this way with these plates. There are a couple guys, a couple of researchers.
Yeah, Donald Lee Smith, Resonant Induction Energy Transfer and Earth Electrical System 2. Donald Lee Smith has demonstrations in videos where he shows using what he's calling a capacitor, which is a copper plate and an aluminum plate separated by a dielectric. I understand it correctly, it's a dielectric material which can be plastic or something that can separate the two plates, copper and aluminum plates. And Rick Friedrich also has a video. I'm trying to think of the name of it. I'll put it in the description. I'll put a link to the video in the description if it allows that. I think it does allow me to put a link in there. So I'll put that in there to the video. So just check the description and it'll be in there to the video where Rick Friedrich is sharing how to basically, for example, with a plasma ball like this. So let me back up a little bit. So Oliver Heaviside, Rick Friedrich calls this the Heaviside. I think he's calling it electric wind, because we all can relate to how the wind can blow a ship with sails across the sea. Well, when the plasma ball's on, okay, this is a little Tesla coil inside there, right? And there's a plasma ball here on the outside, and there's the I'm trying to think how to say this. There's an energy around here. It's called, I think Thomas Bearden calls it the Heaviside component, if I recall correctly. And Oliver Heaviside wrote extensively about this energy around around what I guess we call an electromagnetic device.
Sure.
Okay, I may not be using the correct words, but I'm just sharing I'm trying to share my thoughts and what I'm working on. So, what I understand Rick Friedrich to be sharing is that we want to cut a hole in copper and aluminum, and for a plasma ball, because Rick Friedrich is using a plasma tube. You can buy them from Conrad's in Germany, but they don't. I think from what Rick Friedrich was saying, you cannot have them shipped to California because they might be, maybe because the gas is inside. I'm not sure. I don't know why they can't be shipped here, and I didn't check that for myself. I'm just thinking that doesn't really make sense because these have gases in them too. So, but if you have a plasma ball like this, it can be used as well. And what Rick Friedrich explains is that, if I understood correctly, and please watch his video for yourself, it's one of his recent videos. I mean, I think he made it like 8 months ago, but it's one of his more recent videos. So, what he's showing is the way he talks about it is, I'm still learning how to talk about this, but I'll do my best, and I will share the process of learning and experimentation along the way. So think of how wind blows a ship, a sail, blows the sails. It pushes on the sails, right? Well, when the plasma globe is on, there's a movement of energy around here. So Rick Friedrich explains we don't want the plasma globe to know, we don't want it interacting with the plates. So we don't want it to do this. Watch how it goes. See how it's going to that right there? We don't want it to do that. We want it to be about 3/4 of an inch to 1 inch away from that, okay? And with a plasma globe, we want to have to make a hole here. And I was explaining to Cameron that the hole has to be big enough that on every side there's 3/4 of an inch to 1 inch. If I remember correctly, that's what Rick Friedrich was teaching, is 3/4 of an inch to 1 inch away from this. And then the plastic as an insulator, this is what we're using, the plastic material. This is a thin plastic. The plastic material that will separate the copper from the aluminum, that has to overlap the two, so that'll stick out on each side. It'll stick out about, yeah, here we go. It'll stick out about, oh, you're showing it? Thank you.
Yeah.
Yeah, so let's go do it on both sides. So let's have this on the inside here. Like, well, so it's gonna look like it'll look like this.
Deeper in.
Yeah, deeper in. With giving about, I think on the outside we want at least a 1/2 inch, approximately, and then where the hole is, we want around the same, around a 1/2 inch, on the inside too, and that's where, and that's so that the metals, because it'll be copper on one side, aluminum on the other side. Here we have copper on both sides, but that we don't have the aluminum cut yet. The aluminum's here, and it's not cut yet. We haven't cut it yet, so that'll be cut at some point in time. That's the sticker on it. So when it comes to using a plasma globe or ball, this will be sitting approximately 3/4 of the way up. So that's half. So let's see, that's like 1/4. That's 2/4 is half. 3/4 will probably be around right there. So it'll be sitting probably around right here, okay? But not interacting with this globe, okay? It'll be about 3/4 to 1 inch away. And then the energy that's flowing up is the energy we want. There's an energy out here flowing up. And that energy will, so Rick Friedrich and Donald Lee Smith called this a capacitor. And if I understood what I was seeing correctly, and I'm still learning how to see this and learning what I'm seeing, but I'm trying to figure out how to connect a capacitor. This is just a microwave capacitor. And this is a full wave bridge rectifier. And Rick Friedrich said we can use MOSFETs. If I recall correctly, we can use SCR, MOSFET, or transistor. Now, I don't understand how to use those myself yet. I've been reading about them, and I'm having a hard time understanding. I tend to learn really well when I just make things, so I might just have to try it and see what it does, and just be very careful. And Rick Friedrich warns, be very careful of the ground wire. So, anyway, this is kind of like an update video, just sharing what I'm thinking about, and excited about this project. And anything else, Cameron?
I think we've got some steps laid out for cutting aluminum, you know, neatly, and using the hole side to get the holes in your materials. So I think that if I bring my hole saws next time, we could get another step or two. I personally want to look up the like the diagram of a couple of capacitors, because I'm still not totally clear myself where the poles are, where the terminals go in a capacitor. So,
Okay.
you know, I think the both of us will probably know that by the next time we work on this. So.
Yeah, and we just have to be really careful, and anyone experimenting with this, be super extra careful. And Rick Friedrich also teaches that you can stack these, if I'm saying it correctly. In other words, so copper and then plastic and then aluminum on top, and then you can keep repeating that. And you can put like 60 plates up, and each plate, the plates don't interfere with each other. It's additive, so you add up the power of each plate. And I'm thinking at the moment, and we'd have to just test it and see, but if we connected all those plates together, that seems like that would be parallel, I guess. If all the coppers were connected together and all the aluminums were connected together, that should allow us to add up.
You know what, maybe the fact that you've got two materials, on one side you've got like a strip running to all the coppers, and you also have a strip running to all the aluminums, and then those are the two poles with the difference. And yeah, that's ringing a bell with what a capacitor is.
Yeah, and Thomas Bearden talks about a capacitor having a lot of access to a lot of energy, and he also talks about anywhere that you have a charge, which he refers to as the dipole, which is a positive and negative, or negative and more negative, as Don Smith explains, that you're having access to basically an endless flow of energy. You can call it energy from the vacuum, or energy from the 0-point field, or you can just say energy from nature.
I just had a brain flash. You know how we were talking about having like an electrical storm under a polyester blanket.
Yeah.
Okay? And you move under your blanket and you've got an electrical storm and you get shocked. We're talking about riding electric scooters. You know, I ride bikes, motorcycles, scooters, whatever. Anything with the wheels and motors, I like it. Why don't we make some sort of machine that rubs something like balloon? The tire. The tire's going to be the balloon. You know how you rub a balloon against your hair or your arm or the carpet, and then it's got all this static electricity? Can we gather static electricity driving around and rubbing something like a brush on our tire?
I really like what you're talking about.
Can we connect that wire, just a brush on our tire,
okay,
and use that to charge a capacitor or something?
I like that.
Or even run this guy.
This is great.
Like
okay.
I feel like you can.
I just bought some books. I'm gonna show you my books I just bought. Okay. The Secret World of Magnets by the father of spintronics, Howard Johnson. I just got this book. That's just what was on top. I'm just going to show you each book I just bought because it's mixed together. Okay, here's another one. This is Electrostatic Motors. This is kind of what you're talking about, right? Electrostatic Motors, new revised edition. Their history, types, and principles of operation. I got this from Amazon. Okay, so we're still streaming, but come on in. Earl's here with us. Okay, welcome, Earl. Okay, so then here we have electrostatic experiments. Okay, an encyclopedia of early electrostatic experiments, demonstrations, devices, and apparatus. Cameron, is this kind of what you're talking about? I just got these books.
I like the titles. I just know that I've seen some sort of experiment which involved like Tesla coils and those really interesting showy arcs of electricity, and somebody had like a conveyor belt or something that ran, and and it was doing what we're talking about. The similar thing as like rubbing a balloon on carpet. It was rubbing a brush or some sort of soft thing on. It must have been like a rotating conveyor belt and collecting the static.
Okay.
So I know it's been done. I can't remember what it's been used for.
A.D. Moore's Electrostatics, Exploring, Controlling, and Using Static Electricity. And then, let's see what else we have. Fundamentals of Applied Electrostatics. So these are some books I recently, I recently purchased on Amazon. And what's this one say? Homemade Lightning, Creative Experiments in Electricity. I mean,
That
I think
one right there. I think
that
the
might
Homemade
be,
Lightning is,
yeah.
is the book we're talking about. What I'm talking about.
Okay, and then, well, this one's, I had this one before, the Free Energy Device Handbook, a compilation of patents and reports. But it seems like these books here, the most recent ones, might be kind of like talking about a little bit on what you're talking about. Because it's all about static electricity and doing something with it, right? Okay, so this is really exciting, and so let me think. Anything else?
No, we're in kind of the planning stage, and next time we can be in the making some pieces stage, and hopefully connect it and get some reading stage.
Yeah, and I do want to say that when I look at this, and from what I've come to understand about what Gerard Morin teaches about, Gerard Morin, Thomas Bearden, and many people teach about how power comes to our homes. When I look at this, I see something very similar to what we're actually doing with the main power grid that powers homes. I see something, I don't know if I'm ready to say this because I don't know if it's going to come out and make any kind of sense, but I'm going to try. And actually we learn by doing, so let me make less sense now and more sense later.
Yep.
I need to hurry up and make less sense so I can make more sense at some point later in time. So here I go. I don't have to rush that either, but here we go. So basically, when I see this, what I see is the power grid that we have right now. That's what I see when I look at this. What do we have? Okay, so we have an energy source, which is the batteries. So the power grid that sends power to our homes, what's similar to me in this is that there's a high frequency. So we're taking these batteries and we're changing them into a high frequency. I don't know if it's like 28,000 cycles per second or 28 kilohertz, or it's between 25 and 28,000 cycles per second. Okay, so when we get over 20,000 cycles per second, that's often referred to as resonance. And Gerard Morin and many others refer to the power lines as a resonance flow. So instead of batteries, the power station has a generator, right? That's what I understand. I mean, I haven't been there. I don't know what they actually have, but this is just, I'm just maybe paraphrasing what I've learned from listening to Gerard Morin, Thomas Bearden, Rick Friedrich, and many others that share what they've learned about the way power's made and delivered. So I'm just sharing my interpretation, my understanding of what's being said and taught by many, many other people. But when I see this, I see our power grid. So I see this would be equivalent to what the power station is sending down the wires. This is what right, it's a resonance flow. It's how do I say this? So imagine a frequency, a high frequency. This is what I'm seeing. A high frequency. There's almost no amps here, right? It's a high frequency coming down the lines, the transmission lines, or the resonance flow lines, I'll call it. And then that goes into a pole transformer. A pole transformer. And I feel like what we're building is, we're building our own version of what a pole transformer does, because a pole transformer is where the amps and watts come from. That's where the energy is coming from, right? It's coming from the pole transformer. So why do I think it's coming from the pole transformer? Well, because on one side we have transmission. We have a transmission side of that's the side for the resonance flow lines that go to the pole transformer. That's a transmission. It's transmitting. It's like a transmitting antenna on one side. And on the other side, this is all inside the pole transformer. On the other side is a receiver. It's like it's a receiving antenna. And there's, from what I understand, there's a space between the two. It's not connected like a regular transformer, like a high voltage transformer where it's all connected through iron or something. And I'm still learning how air cores work, like the air transformers, air core. I think that's the name of it. I don't totally understand that. I think that might be more similar. Maybe that's more similar to a, no, I don't know if it is or not. I still have a lot to learn. But I'm just telling you what I see, the association I make. So this gets, where does all the energy come from in this system? This is just exciting if I say the energy around it. And then that excited energy that's around this, which is going to be captured by this capacitor, right? And then how this is grounded is very important. Rick Friedrich talks about how, and again, I'll put the video, a link to the video in the description of this video. If it allows me to do that, I'll do that. Rick Friedrich talks about the ground is very important to be very careful with because the electrons are flowing in from the ground, right? If I understand it correctly, they're flowing in from the ground. And then because they take the path of least resistance, you have to have a resistor in the, if I understand correctly, you have to have a resistor in the ground line. And I'm still learning about resistors and how they work and everything, so I don't know, I don't understand what I'm saying right now. I'm just repeating what I'm learning. I don't know the meaning of what I'm learning yet. That comes usually in my experiments. That's when I learn what things mean. And I see how they work, and then I know how they, what the meaning is. So, but Rick Friedrich talked about a resistor being in the ground line, and what that does is the electrons flow into the, so there's like I think like a heartbeat, like they flow in and then they want to flow back out, but with the resistor there, so they flow in to your circuit, and then the resistor stops them from flowing back out, and it takes the path of least resistance, which is the load, if I understand correctly. So I have a lot to learn still, and I'm just kind of sharing the journey. Cameron came over. We're going to ride scooters tonight with Earl as well, and we're just going to have a scooter ride night. But I thought, we were having this conversation. I thought, Cameron, let me stream this. Let's kind of document our thoughts. So you guys are getting direct access to our personal journals. It's called a video journal. I think some people call it a vlog. Is that
I think so.
Yeah, and it's just sharing our thoughts. So we're sharing our thoughts, and we're sharing what we don't know, but are excited about learning. So again, I'll put the link to the to Rick Friedrich's video where I'm referencing to, and if you want to study a lot more about this, study Rick Friedrich's videos, study Donald Lee Smith's videos, and study Thomas Bearden, everything you can learn about him as far as it relates to these projects and scientific discovery and understanding, and it'll help provide like the foundation for a language of understanding what we're doing and what we're trying to learn. So what else? I don't know if I finished my story, but so the story I was telling was the power lines that we get our power, that powers our homes. If the energy is coming from, if it's coming from the pole transformers, in a similar way, the energy for this capacitor, which is what it's referred to as, I'm kind of seeing it like a battery, but a battery and capacitor are very similar. And maybe as I learn more, I'll see it's less like a battery and more like a capacitor. But right now, I think of it as a battery. It's kind of like self-charging and has access to endless energy, because what do we know about the universe? We know that energy is interconnected, if I say it that way, throughout all of space and time. That's the way I understand it. All energy is connected. So this energy right here is affecting the furthest reaches of space. And the furthest reaches of space is helping to power this. It's just the way energy works. So there's plenty of energy, I guess. All right, Cameron, should we go ride our scooters?
I say we ride scooters, and I'm gonna be sort of daydreaming how many feet of fluffy stuff would I have to rub on the ground behind my scooter to completely power the scooter? Because
I like that.
I know that I could. I know that. I know I can.
You want to power your scooter with static electricity?
With bunny hair. Bunny fur is how I want to power my scooter. Static electricity.
Oh gosh, I like that.
Thinking about it.
I like that. Okay, well we'll have to work some numbers out on that.
Yeah, it's just you have like a really long bunny tail on the scooter, and it'll be enough to just power it. And I'm kidding, but I'm not kidding.
Well, I hope to be able to share in greater simplicity and greater clarity as I continue to learn what I'm doing. Okay, everyone, have a great evening and a great day, and happy experimenting, happy learning. Take care.
See you later, people.
Bye-bye.